In this video, we're going to be taking a look at how to create scatter plots so that we can use them in graphical analysis for our experimental data. Scatter plots you may have already done before, some of you may have, but today we're going to learn how to do scatter plots like a pro and make good, solid ones that scientists like for making graphical models. A scatter plot is just a set of coordinate axes that has points added to it, like we see here. And when we do this for experimental data, we want to make sure that we're putting our variables in the right spot. The independent variable goes on the horizontal axis, that's why this is labeled I, and the dependent variable goes on the vertical axis, so you can see this is labeled D. This example is for the volume and weight of the beaker from the coordinate axis video. Volume was measured in milliliters, and that was on the horizontal axis because that was our independent variable, and our dependent variable was weight in grams, and so that's on the vertical axis. So our labels should look like big picture quantity that we're measuring, and then in parentheses after it, what is the unit of measure that we're using to measure that quantity. So for the volume, we were measuring that in milliliters, so we would put V for volume, and then in parentheses after it, ml as abbreviation for milliliters. Our dependent variable was weight, and so we would put W or something like that for weight, and then in parentheses after it, the unit that we used, which was grams. We won't want to just label the unit, so don't put just milliliters or just grams on a scale like this. Put the big picture quantity first, and then in parentheses after it, put what is the unit that was used to measure that quantity. Another important thing is to make the scales uniform. One step in the right direction for this is always start your axes at 0. There are a few special circumstances where it makes sense not to do this, but in all the cases that you're going to see in this class, you want to start your axes at 0 because it gives us a truer picture of the data. Another thing that's important is make sure your scales are the same size. The tick marks need to be equally spaced and have the same value. So the example that I'm showing here, on the horizontal axis, the distance between 200 and 300, represented by the blue arrow, is much greater than the distance between 300 and 400, which is represented by the red arrow. Both of them are the same amount of milliliters, and that can distort our data and make it difficult for us to get a good picture of what our data represents and build a good, useful model. So these pointers will help you make good scatter plots, which are the foundation of all the graphical analysis that we're going to do to try and make sense of data in science.